This video will be about the second part of the healthcare technology life cycle, the management part. The healthcare technology life cycle will be separated into two main parts, the planning part and the management part. The bridge between them will be the deployment phase, and the outcomes will be used as a feedback for the planning part from the management part. The management part will be separated into four phases: education, compliance, maintenance, and safety. I will start now with the talk about the deployment phase, which is the bridge between the planning part and the management part. There are many deployment activities, including the plans for the receipt of the product, the installation, the acceptance testing, check-up for preventive maintenance inclusion or exclusion, and other deployment activities. It's important to involve the key participants early in the deployment process. This includes the constructions, facilities engineering, electricians, architects, device users, etc. Another important point is the facilities consideration. The facilities considerations should include the physical space requirement, structural requirement, shielding requirement, the electrical power requirement, heating and cooling requirement, and finally the plumbing requirement. For large items such as the imaging systems, laboratory analyzers, and sterilizers, the facility must be prepared well for the deployment of such technology in the hospital. I will take from our previous practical example the installation for a new MRI machine, 1.5 Tesla MRI machine. The required space will be around 25 meters square, and the weight of the magnet coil of the magnet will be around 4 tons. So this will be the practical example for the deployment phase and part of the activities in the deployment phase. We can see in this slide the functional diagram for an MRI suite. The functional diagram will separate the MRI suite into 4 zones or safety zones. The zone number 1, which will be the outpatient entrance, the safety zone 2, and the safety zone 3, and safety zone 4. Also, we should have talk about the space requirement. This will be reflected in the MRI suite key plan. We have the main MRI scanning room, we have the control room, and other rooms. For the shortage of time, I will only talk about the MRI scanning room and not in depth, just a brief talk about it. The MRI, we can see here different drawings for the MRI scanning room. We can see the floor planning drawing, the reflected ceiling drawing. Also, we can see here a cross-sectional view for the MRI scanning room and another drawing for the MRI scanning room. It's important in every room to consider the facility requirements. As I said before, I will only focus about the MRI scanning room. So we have different facilities requirement, the architectural, lighting, power, the communication and special systems, the heating, ventilation, and air conditioning, or what's also known as HVAC. And finally, the plumbing and medical gases. These requirements will be based on the standard and guidelines. For example, in the USA, they use the FGI, which is the Facility Guidelines Institute. So the facilities requirement will be important. We should consider the same requirements for every room in the hospital. Here also the required equipments in this room. As you can see, we have a list of the equipment. We have the specific code for each item, we have a nomenclature which is shows a specific name which can be used in any room in the hospital, also with a description, the required quantities for this. So this is an example for the deployment, the installation requirement in the deployment phase. As we said before, there are many other activities, like for example, the acceptance, the acceptance testing, the check up for the PM inclusion or occlusion. This will be applied also for the MRI machine or any other machine. As here an example for the preventive maintenance inclusion or exclusion. As we can see, for each device we should have a risk number, and based on this risk number we will decide if this device will be included or excluded from the preventive maintenance schedule, and the required period, if it's annual or semi-annual or other period. Also, another point we should, when we make check up for the PM inclusion or exclusion, is required time for each device, and we multiply this by the number of devices or the quantities, and we can determine the total number required, or the total time required for these the medical devices. And finally, we can calculate the total time which is required to be added to the task in the PM schedule. So this is another point which also should be considered during the deployment phase. Here, how we can calculate this risk number, as shown here from the previous practical example. I will consider only the intensive care unit. We have the patient monitor, the central station, and the adult ventilator. As we said, we need an 8 patient monitors with a central station and 8 adult ventilators. The total score for the patient monitor will be 10, which means that we need to have an annual maintenance for the patient monitor and the central station, whereas the risk number for the adult ventilator will be around 17, which means that we should have 2 PM, preventive maintenance annually. So it's a semi-annual. The required time for the patient monitor for the preventive maintenance for and inspection and preventive maintenance for the patient monitor will be around 50 minutes. For the central station will be around 35 minutes, and for the adult ventilator will be also 50 minutes. So the total time to check up or to make the IPM for 8 patient monitors will be around 400 minutes. For the central station will be 35 minutes, and for the adult ventilators will be around 800 minutes. So if we add this number together, we will have how much time needed for the IPM, the inspection and preventive maintenance, for the new equipment in the intensive care unit. Similarly, we make the same calculation for the other machines. For example, for the CT scanner, we should have either a semi-annual or every 3 months. The period will be 180 minutes, which means 3 hours. In case we have 2 preventive maintenance, that means we should have 6 hours for the annual preventive maintenance of the CT scanner. Here, how we can calculate the above risk number. Here an example for the patient monitor, for the central station also, and for the ventilator. After the deployment phase, the second part or the first phase and the management part will be the education. The education, as we said before, should be done for 2 types or 2 categories. The first type or group will be for the users. The second part will be for the clinical engineering staff. For the user trainings, the training should be take place before the first use in the patients. This because of the safety, to ensure that the use of this device will be safe after appropriate training have been given for the users. We have what we call the super users. Usually in each department we have personnel with special skills and experience. We call them the super users. We usually train the super user, and and then the super user will train the rest of the staff. Also, some departments having a staff devoted to the training, such as a nurse educator. It's preferable the first training to be done by the professional trainers from the manufacturer. Another point which also should be considered during the training, after the passing of the first year, we make what we call the competency test. The competency test is to assure that the user still have the enough information about how to use this equipment or device. A second phase in the management part will be the compliance. The compliance will be with the regulations, the standards, and the accreditation organization, and this will be essential and critical. Here an example what guidelines or standards. Here we can see the standards for IEC for the medical devices. Here also another example about the accreditation organization. One of the most important of them is the Joint Commission International, or what's known as JCI. In Lebanon we have what you call the HAS. The third part in the management, the third phase in the management part will be the maintenance. As we said before, a check-up for the preventive maintenance inclusion or exclusion will be done in the deployment phase based on a risk number. We should make what we quality assurance inspections and maintenance, and this is required for most medical devices and systems. Schedule the preventive maintenance and safety and performance testing are necessary in order to keep the clinical technology running properly and safe for the patients. In case of failures occur, repairs are implemented. Also, the retraining of staff if this failure as a result of a user error. So maintenance is a very essential part. It's important to mention we have different type of maintenance. We have the preventive maintenance, which is done in a periodic way. For example, every year or every 6 months. Depends, as we said before, in the risk of this device. But currently we are moving to another type of maintenance, which is called the predictive maintenance. So the maintenance has passed through the history in 3 phases. We start with the corrective maintenance, then we passed to the preventive maintenance, and currently we are using the predictive maintenance. So what is the difference between the preventive maintenance and the predictive maintenance? This also has been covered in the previous videos, which is the IPM form. For example, for the ventilator, this based on the Fluke biomedical inspection and preventive maintenance. The inspection and preventive maintenance for the ventilator will be separated into 4 parts. The first part will be a physical check-up for the ventilator. The second part will be a check-up for the electrical safety. And the third part will be a preventive maintenance performed based on the manufacturer's recommendation. And the last part will be about the performance testing for this device. And this will be based on the IEC requirements or another requirements, depends on each country. For example, if it's IEC, this will be the IEC 60601-2-12 2009. Similarly, the electrical safety should be done based on the electric in the IEC 6061-1-1. So as we said before, we currently move from the preventive maintenance into the predictive maintenance. So what is the difference between them? Usually in the preventive maintenance, as we said before, it should be performed in a specific period, usually every 3 months or 6 months or 12 months or as needed. However, in the predictive maintenance, we gather data from each device in a daily basis, and we make an assessment for each part or each component of this device. And based on this assessment, the period will be adjusted. This will be having a better support for the device because usually I will give a simple example. In case of a ventilator, usually in annual or every year, we replace the oxygen cell, whereas the replacement of the oxygen cell will not be anymore depends on the period, will be more based on the condition of this oxygen cell. So a daily check-up of the condition of this, for example, in case of the auto cell, we check the millivolt value of this. If it's close or near to the 5 millivolt at a 21% oxygen, which is in the medical air, this means that we should change this auto cell. For this, we make a daily check-up for this component, and based on this, we recommend how much or when this component will be replaced. So the predictive maintenance is a better choice. It's more cost effective and more reliable than the use of the preventive maintenance, which is only based on a period without taking into account the conditions of the components in each device. Also, another point which I should mention, the preventive maintenance now become available for many reasons. One of them is the automation. Another reason for this move or the transfer into predictive maintenance is the integration of the medical devices with the health system and the integration between the CMMS system, which is the computerized maintenance management system, with the health system. The health system is the hospital information system. So it's become more easier now to perform the predictive maintenance by comparison to the limitation in the previous years, where we have an isolated medical devices or systems which are completely isolated from the health system or the CMMS system. So now predictive maintenance has become a better choice and is now more adapted in more hospitals around the world. So we start with a talk about the deployments, and we move to talk about the education. Then we talked about the compliance, then maintenance, and now we'll talk about the safety. The safety is an aspect of the key importance is assessing the risk of the device and the implications for the patient safety. One of the main reasons for the beginning or the start of the clinical engineering domain is the patient safety and the risk for the especially for the electrical safety, which has led to the need for the clinical engineering departments in each hospital. So safety still is an important point for us, and we should consider in order to ensure that the devices are safe to use with the patients. And another point to ensure that operational errors and safety issues are fixed prior to have a risk on the patient or even the operator or the user of this medical equipment. In case of having an error or a safety issue, an action will be taken to solve this problem. Finally, the disposal of the medical device. All technologies reaches an end life and should be disposed and taken out of the service. This could be for many reasons. One of them, when it breaks or when this device breaks or system due to an expensive maintenance cost. Another reason will be the safety issues, as we said before. In case we have safety issues considering the use of a special device or equipment, in this case we need to remove it from service and dispose it. Another reason is the regulatory prohibition or obsolescence. Obsolescence, or when the device become obsolete, a notification will be received from the vendor or supplier about that this device is obsolete, and there are a limited time prior to be should removed from service. Another reason is, as we said, the regulatory prohibition. Prohibition will be, for example, in Lebanon, as I said before, the formaldehyde gas, which is a cold sterilization, has been prohibited in Lebanon. So this is another reason to dispose this device and remove it from service, to take it out of the service. Also, age by itself, it's not a reason to replace the requirement, but sometimes the age by itself is another reason. For example, in case of a new technology is emerged, so we need to replace old technology. But we should focus about important point in the disposal, which is the proper disposal of equipment. We should take into the account the environmental requirements. Another point which is important in the healthcare technology life cycle will be the data collection and analysis and the outcomes. The data collection and analysis is important, as we said before, in the planning part and in the management part. The outcomes also is important to have the feedback from the management to the planning part. So data collection and analysis. An essential aspect of the healthcare technology management is the collection of information, data, and measures which have been shown in the previous chart as a gray circles. In the planning part, the data collection will be the constant monitoring of the technologies. The marketplace, what we mean by the marketplace, the available brands and so on. The safety issues in case we have a hazard recalls and alerts, insurance coverage, and clinical outcomes. So we should always make a collection of data and analysis in the planning part. Technologies, for example, sometimes, as we said, we have new emerging technologies or trends, new medical equipment trends. This is important to gather information about it in case we need to make a decision for the procurement of a new device or the replacement of our old technology. Also, data collection and analysis is important and essential in the management branch. This data would include the reliability, the support cost, recalls, and user errors. As we said, recalls or hazard recalls is very important to be taken into account, so in order to ensure that our medical devices are safe to use. Also, another important point which we can collect information and data about is the user errors. In case we have a large number of errors, we should take an action, which is either the retraining of the staff in the proper use of this medical device, or maybe some modification or the remove of the device itself in case we cannot improve the situation. Here's an example of the reporting which are gathered from the management part. This is a work order trends detailed taken from the computerized maintenance management system, which is the CMMS. It shows that the reason behind the work order, as we can see, the large number of the work orders due to no problem found. No problem found. This means what we should enhance our make a modification for the policies and the procedure regarding the work request issued from the different departments. Also, we can see other reasons for the work order. So we should gather this data, make analysis of this data, and based on this analysis, will we make our recommendations and take action. Finally, the outcomes, as we said before, the experience in the management part will be gathered and bridges back to the planning phase to improve decision making in the planning cycle. Finally, thank you.